All right. So what we talked about yesterday, we talked about that this was area under the curve, the exact area. And because there's an equal sign, that means that this integral literally means area under the curve. This is the called the lower limit. Lower limit. And the b is called the upper limit. And when I say the word limit, don't get that confused for like a literal limit like we've been doing in the past. So what does this mean? Well, of course, remember, guys, the f of x is like your height. The d of x is like your width. Width of what? Of a rectangle. And this means that you're adding up an infinite amount of rectangles under the curve. So that's how we got the exact area. So scenario one, all the areas above the x-axis. So we're talking about signed area. Signed area. And I'm putting them in quotes because technically area is always positive. So signed area. So all the areas above the x-axis, here's A, here's B, and I have some curve, and that's f of x. And I just go from A to B, and that's what we're talking about. So that's what this is talking about. So this is like integral from A to B of f of x. And because it's all above the x-axis, we can ensure or assure, can we use both the same way? That will assure us that this area from A to B of f of x dx will always be positive. Okay, and I said area of f of x dx. This integral means area under the curve of f of x from A to B. Excuse me. That's all the coffee from over there. Cool or not cool? Have I said anything that confuses anyone? Okay. Some area above the x-axis, some below. So that's like something like this. I have a curve and it crosses the x-axis. Here's A, here's B, and we're adding up all this and we're adding up all that. We cannot ensure that this is positive. It depends. If we have more area above the x-axis than below, then it's positive. If we have more area below the x-axis than above, then it's negative. Cool or not cool? Ask me, Kanduru. Ask me. So here it is. I'm exaggerating quadrant 4. I'm going to say here's A. I'm going to say here's B. And I have a curve. That curve, I'm going to call it f of x. And the area from A to B, I'm going to say this is B. Since I'm below the x-axis, that is going to be negative. A to B of f of x dx equals, less than. And that's how you say negative. We're talking about signed area, guys. And if you're wondering, like, Chav, how are we going to get negative area? I don't understand. Well, don't write this down. Just listen. If we're talking about a train or a car that's moving 50 miles per hour, so I'm going to say 50 and I'm going to write MPH. And from hour 1 to hour 3 here. And it's just constant. If I were to ask how many miles did he travel? Well, if I were to ask what direction or what is this area here? Well, notice this gap is 2. The difference between 3 and 1, right? 3 minus 1 equals 2. That's this. And then 2 times 50, that's 100. So this right here will be 100. But because it's negative 50, this will be negative 100. And I should have put a negative in the front of that because it's below the x-axis. So there it is. So it really is just kind of like a vector. It's just giving you directions. If someone were to ask what's the distance traveled, you would not say negative 100. You would say 100 meters, 100 miles, whatever it may be. But if someone tells you in what direction, 100 miles to the left. Sorry, that was the truck outside. Cool or not cool? So we're just talking about signed area. So that's negative 100. And then, of course, these are just some names, guys. The integral sign, upper limit, like we were talking about, lower limit. This is where you start. This is where you stop. F of x, a function. Dx acts like this acts kind of like delta x, and it says x is a variable of integration. So what we're integrating with, integral of f from A to B, and there it is. So this is just like some notation. You don't have to write anything down necessarily. And remember yesterday we called this a dummy variable because it doesn't matter what the x-axis is. See, I put A to B, f of t, f of u, f of x. Okay, so if I have this, I'm just making it up, guys. You don't have to write this down. I'm just going to do the same example, 50, and I'm going to put 2. No matter what you do, regardless of what you call this axis, 50 times 2, that's still 100. I can call this the x-axis. I can call it the u-axis. I can call it the v. I can call it the z. It doesn't matter what you call it. This will always be 100 if you have something that looks like this. Does that make sense? So that's why sometimes this is just called a dummy variable. It does not matter. They're all going to be the same. All are equivalent. That's not to. There's something called use substitution. We'll get there when we get there. We're still rookies. That's a little different, but we're not there yet. Cool or not cool? All right. And these are just properties, guys. I think it's really easy to understand. I think. I don't know. Maybe it isn't. I wish it would have left us as B to A, but okay. So let's think about it. So I'm going to write A to B because that's all we've been doing lately. So this is this area under the curve. A, B. If you flip, so this right now is positive. If you switch the limits, you start at A and you stop at B. So I started at A and then I added all this area all the way to B. So if you switch the limits, so I'm going to go A to B, that's still the same one, f of x dx. If I switch the limits, B, start at B and end at A, then I have to put a negative on the outside. I'll give an example. So let me give an easy example. All right, here's an example. So we're gonna make a linear line because that's the easiest one. So I'm gonna say 0, 2, and I'm gonna say this is 10. And if I go area under the curve from 0 to 2, and if this is 10 dx, that's my f of x. Well, this is just a rectangle, right? What's that area? 20. So how do we get that 20? You can get that 20 by doing 10 times, and then you just go 2 minus 0. Upper minus lower. Do you agree that 2 minus 0 is 2 and 2 times 10 is 20? Okay, but look what happens if I do this. Look, that 2 is this one. That 0 is this one. Upper minus lower. B minus A. What if I do this? Integral? Not negative. I'm putting 2. 2, 0 of 10 f of x. 10 dx, sorry. I hope I'm not confusing you guys. 10 dx. That's this guy here. But instead of going, I'm going to go 10. And instead of going 2 minus 0, I'm going to go 0 minus 2. Upper minus lower. Let me go ahead and do that. So I'm going to write integral a to b of constant, that's a constant dx, equals that constant parenthesis b minus a. That's a formula. So I'm taking my b minus a, and look, you get negative 20. Why do you get negative 20? What's the concept behind this? You're starting, okay. I'm going from 0 to 2. I know to get that width is 2 minus 0, but you're going from 0 and you're going all the way to 2. You read the graph left to right, and I'm finding all this area. This one here tells me that I start at 2, and I have to go backwards. So if I go backwards, then I have to count, it's like counting backwards, so that would be like a, does that make sense to you guys? Yeah, so it's like if I told you find the area of this curve, here's my formula, 10 times upper minus lower, 2 minus 0. That's my 20. Well, if I do this one, 10 times upper minus lower, 0 minus 2. Oh, look, negative 20. Okay. Here we go. All right. So there it is. So we got that one correct. This one right here, 0. Well, because look, guys, if you start at A and you stop at A, have you even moved? No, you haven't moved. You haven't moved anything. So if you haven't moved, it's just 0. Make sense? Okay, I think we're good with this. This one just means you can take the constant out. So if I have a function like the top one here, see how this function was 10? It's just a linear line. So if I have, I'm going to say f of x is 10. So if I say g of x is 3 times f of x, well, that just means 30. So if I were to go integral 0 to 2 of g of x dx, well, that means this. Integral 0 to 2 of 3 times f of x dx. That 3, I can just move it out to the outside like this. 3 integral 0 to 2 of f of x dx. Well, 3 times this right here. That right there was this. Don't worry, this is just a proof. I'm doing this one right here still. F of x is just 10. And 10 times 2 was 20, so I put a 20 here. Oh, I get a 60. Well, would I have gone to 60 if I would have just gone right into 3 times f of x? Well, let's see. 3 times 10 is 30. So if I would have drawn, just write this down. Just listen. You don't have to write this down. There's my 30. Here's 0. Here's 2. Look, guys, that area is going to be 60 anyways. Do you see that, guys, or no? Maybe I'm going too fast. No, d of x is just the change in x. And every integrand needs a dx. Dx just means your the delta x, and we're just summing an infinite amount of rectangles. This is we're just doing symbolic. Yeah, we're just doing symbol right now. You know what I mean? We're just finding area under the curve, and yeah, yeah, yeah. Every integrand needs a. We're gonna do the fundamental theorem of calculus, and you're gonna see like how it's all connected. But for now, all we know, we're just doing symbolic. That integral symbol literally means area under the curve, the exact area from right here, from this guy right here. That's all we're doing. So we're just doing properties of that. Are we okay? Okay. All right, guys. This -1 that acts like a constant. So if you have a -1 in the front, I can just bring it to the front here. So that's not a big deal. I don't think we'll have any issues with that. You can add and subtract different like f of x plus g of x as long as the limits are the same. I think this is pretty easy because that's kind of like the same how it is for limits as well. This is the one that we need to chat about real quick. So I'm going to draw a graph, and I'm going to have a curve, and here's f of x, and I'm going to say this is A, and I'm going to stop at B, and I'm going to go to C. I'm going to try and color code. So this is the area from A to B of f of x, and I'm going to go plus, and I'm going to put this in blue, and I'm going to say this is the area from B to C of f of x. And I want you to notice, if I add the area in red with the area in blue, would that give me all this area in black? Yeah. So I can say all this two integrals added together is the same as the area under the curve from A all the way to C of f of x dx. See? And in a little bit, we're going to rewrite that, just like with algebra. What if I just wanted the area in blue? And you're given the area in black. So, do you agree the area in black minus the area in blue? Did I say I wanted the area in blue? Okay. The area in black minus the area in red, do you agree that gives me the area in blue? And look, guys, you can treat this like algebra. Look, this is like individual little pieces. So I could easily say, if I want the area in blue, I can say area under the curve from A to C of f of x dx. And if I subtract the area in red, the area from A to B of f of x dx, that will in fact give you area from B to C of f of x dx. So you can kind of treat this like algebra too. And you can see that. Look, here's this region in black there. And look, I subtracted. If you move this to the right, that's subtracting. See? And you're left with the area under the curve from B to C of f of x dx. Ask me, Rodriguez. Lehman.
No, sorry, I was reading just writing down the wrong.
Yeah, I might have twisted my words. So I'll check my video tomorrow or tonight when I get home. But yeah, but do you see how that makes sense, guys? Like if I want this region here, you can just move that to the right, and you go that minus this one will give you this one in blue. Okay, perfecto. That sounds so perfect. Okay, go to the next page. We're done. Now we're just going to use our properties. So here we go. So relax, guys. I do not know how this curve looks. If you want a visual, I mean, I don't know. You guys are visual, so I'm going to write -3 and 0. And I don't know, maybe this curve here, maybe this area is square root of 2. Because square root of 2 is a positive number. I'm not saying that's how it looks. I just drew some random thing. I could have a little bit below the x-axis, but since it's a positive number, I just did that. Okay, notice, I'm counting backwards. I start at 0 and I end at -3. So if I count backwards, what do I do with that square root of 2? Negative square root of 2. That's it. You're counting backwards. Does that make sense? No? Okay. Ms. Kanduru, we did it over here and you told me that it did make sense. Okay, well then let's absorb. Observe and absorb. So I gave you a formula. Okay, no, relax. Look, I give you a little formula here. If I have a constant, let me answer that really quick. This is Chavez. Yes, ma'am. I do. Okay. Bye. Chavez, you're going to be leaving, but please make sure to watch my video. All right, Kanduru, you see this little formula here? I gave you. You have a constant, and I want to find the area under the curve from A to B. You go constant times the difference of B and A. Well, in this case, my 10. 10 is a constant. So 10 just means y equals 10 like this, right? So look, how do I find that area? 10 times, and then upper minus lower. 2 minus 0. So 10 times 2 gave me 20. Do you agree that this area is 20? Yeah. Now look what happens when I change the limits. Now I start at 2 and I work my way towards 0. So using my little formula, 10 times 0 minus 2. OMG, it gave me negative 20. But that area is 20. Why is it negative all of a sudden? Because I'm going backwards now. Yeah. To see what I did there? So, going back to our problem. So now look, check it out. Now going back to our problem. Look at this. This was from negative 3 to 0, and it was square root of 2. Now look what they did with the limits. 0, negative 3. So it's just going to be negative square root of 2. Does that make sense? Yeah. Okay, we're good. Yeah. All right. See, so you did know. But now it clicks, all right? Okay. All right, next one, guys. Look at letter B. Lower limit is negative 3. Upper limit is 0. Oh, they just changed the letter. They just changed the x-axis and called it a u. Is it going to change anything? No. It's a dummy variable. I can just call that square root of 2. Are we still okay? Next one. I have a negative in the front. My limits are the same. I can put that negative. I can take that negative out and put it right there. So negative integral negative 3 to 0 of g of x dx. I already know that the integral from negative 3 to 0 is square root of 2, but because of that negative, it's going to give me negative square root of 2. Not everyone at the same time. Okay. Again, this is a constant. You can rewrite this as integral negative 3 to 0, 1 over square root of 2 with a gr like this on the side. And then this guy, you can just move it to the front. 1 over square root of 2 integral negative 3 to 0 of g of r dr. So this is just going to be 1 over square root of 2 times square root of 2. I have a square root of 2 in the numerator. I have a square root of 2 in the denominator. So this is just going to give you 1. Or square root of 2 over square root of 2, but which is just 1. What's up, Kanduru? Why you no like? Well, that's what the area under the curve from negative 3 to 0 is. Look, it tells me right here. This is given. Well, because this says right here, 1 over square root of 2 times that in brackets. And that in brackets is the square root of 2. No, just ask. Ask and we shall deliver. It sounds like Domino's. I'm not a pizza delivery person. I'm just delivering math here, you know. It's just 1, yes. It's just 1. 1. All right, go to the next one, guys. Should I do a visual for this? Okay. I'll do a visual when it comes down to it. I'm not going to put to scale because, all right, so let's see what they give us. Focus, Mr. Drew. From 1 to 2, I have negative 4. From 1 to 5, I have 6 of f of x. And the area under the curve of g of x from 1 to 5 is 8. So let's do it again. Area under the curve from 1 to 2 of f of x is negative 4. Area under the curve from 1 to 5 of f of x is 6. And area under the curve of g of x from 1 to 5 is 8. Are we okay? All right, first one, letter A. I start at 2 and I stop at 2. Have I moved at all? Because if you haven't moved, what's this answer? 0. Next one, it says letter B. I start at 5 and I end at 1 for g of x. Well, I started at 1 and I end at 5, and that area of the curve is at 8. So this one must be negative 8. Period. Next one. That 3, I can bring it to the front here. So I can go 3 integral 1 to 2 of f of x dx. So what is the area under the curve from 1 to 2? Do they give me that? Yeah, they do. So this is going to be 3 times negative 4, which is negative 12. Okay, we reach our first pickle. Relax, it's not even that bad. So here's a visual, not to scale, because obviously I see that I have area that is negative. So this is not to scale, guys. Okay, I'm just gonna draw first quadrant. I'm just gonna draw a curve. And if you have colored pencils goes really good on this one. Let's see, do they give me, yeah, 1 or 2. 1, I'm gonna say 2 is right here, and I'm gonna say 5 is way over here. If they give you the area 1 or 2, and 1 or 5 is the other one, and they give you the area in the blue from 1 to 5, how do I get, you know what, let me color it a color. Let me color it purple. How do I get that in purple? I take the blue and I subtract the red. So let me show you what that means visually. So I subtract the blue. So I take the blue. So the blue is integral from, and let me color code it. The blue is integral from 1 to 5 of f of x dx. And I'm going to subtract, so neutral is black. I'm going to subtract the red, which is integral from 1 to 2 of f of x dx. And what will this give you? This will give you the stuff in purple. Let me put black, the equal sign in black. This will give you the stuff in purple, which is integral from, let me write it in front of this, integral from 2 to 5 of f of x dx. Does that make sense? Okay. Hopefully that made sense to everyone. I'm going back to a neutral color. I'm going to go to black. Area under the curve from 1 to 5 of this whole function of f of x is 6. I'm subtracting the area under the curve from 1 to 2 of f of x, which is negative 4. 6 minus a negative 4. 10. Did that make sense to you guys? Yes, we're winning, guys. We're winning. All right. Here we go. This one, we can just separate it like this. There's a minus in the middle. There's your difference formula there. So I can go 1 to 5 of f of x dx. And I can subtract integral from 1 to 5 of g of x dx. So I take my 1 to 5. Let's see, what was it? 6. 6 minus 1 to 5 of g of x, 8. And I'm going to get negative 2. Are we okay with that one, guys? All right, same thing with this. There's a 4 in front of the f of x, so we're just going to split it up. 4 integral 1 to 5 of f of x dx minus integral 1 to 5 of g of x dx. 4 times the area under the curve from 1 to 5 of f of x, which was 6, minus area under the curve from 1 to 5 of g of x, which was 8. 4 times 6, what's 6? 6, 12, 24, minus 8, so 24, 14, 16. The 4 is in front of the f of x. I see a bracket here. I think we're good. Unless, okay. We doing okay? I don't know what's going on.
Sorry, I stuffed this in my second lunch and I forgot about it. It was just hanging
Oh,
there.
well, now you have it. So, now you can eat some peanut butter. Okay. Let's go to the next one, guys. This one's coming from the Demana textbook. That's our textbook, technically. Demana text. 4th edition. So don't worry, guys. We're almost done. Look, we just have, and it's just a graph that takes up takes up space. We'll do a few questions together on delta in a little bit. All right, here we go. So I have a function, the area under the curve from negative 1 to 1 of f of x is 5, from 1 to 4 of f of x dx is negative 2, and the area under the curve from negative 1 to 1 of h of x is 7. All right. I wish they would have told us if f of x is even or odd, because one of these is possible if they would have told us something about, we'll get there when we get there. Find each of the following integrals if possible. There's some that are not possible. Area under the curve from x equals 4 to x equals 1 of f of x. Well, I have this one from 1 to 4. So if I reverse the polarity, if I reverse the limits, then this has to be 2. Letter B, area under the curve from -1 to 4. Yeah, I can figure that one out. That one's going to be area under the curve from -1 to 1 of f of x dx. Where this one stops, the other one better start. Plus, from 1 all the way to 4 of f of x dx. So there it is. Where that one stops, this one starts. And now it connects them. Do you guys see that? And so this area, that's the area from -1 to 4. So I'm going to go 5 plus -2. I think I did everything correct. So that is 3. Does that make sense, guys? Okay. This one here, -1 to 1. Yeah, it looks like it is going to be possible. 2 in the front, -1 to 1 of f of x dx. Plus 3 in the front, -1 to 1 of h of x dx. So let's see, 2 times -1 to 1 is 5. The area under the curve from -1 to 1 of f of x is 5. Plus 3 times from -1 to 1 of h of x is 7. So let's see, 10 plus 7, 14, 21. 21. So this answer looks like 31. This one. If, okay, and I'll slow down. If, and this is you're gonna see this happening. If they would have told us that f of x is an even function, they don't. But if they would have told us that it was even, it would be possible. Chop, I don't even know what an even function is. Okay, just pretend here because it's not to scale. If they would have said this, don't. As a matter of fact, don't write this. Just listen. So -1 to 1, and I'm going to say this is f of x. So if I were to tell you that this area under this curve, if I were to told you that that is 5, could I figure out what the area under the curve from 0 to 1 is? Yes, because it's symmetric on the y-axis, and we would just take that 5 and divide by 2, and then we would say this answer is 2.5. If they would have said that. Do they tell us anything about the f of x being even or odd? No, because they don't tell us, not possible, because we don't know. We don't know. So not possible. Like there's nothing you can do. You can't subtract. See, you have -1 to 1 and 1 to 4. And if you subtract the 1 to 4, all you have, there's nothing. You guys know what I'm trying to say? Let me draw a picture. You have the area from -1 to 1. And then I have the area from 1 to 4. So see, like you have this area, -1 to 1, and then you have this area, 1 to 4. There's nothing you can do to figure out from 0 to 1. Like, yeah, you can subtract the green. Okay, now what? Yeah, you can add them up. You can subtract the red, and you'll know from 1 to 4. But there's nothing you can do to manipulate it to just get the area from 0 to 1. Do you know what I mean? Like, there's nothing you can do to get this specific area, 0 to 1. Like, see, there's nothing you can do. You can't. There's nothing to manipulate. Hey, don't fall asleep. That's the merit. Okay, so not possible. Cool, not cool. All right, let's go to the next one. -2 to 2 of h of x. Well, look, guys, is -2 to 2? Are you inside the domain of what they give you? No, we don't know what happens outside of -1, to the left of -1, and to the right of 1. So you don't know. So not possible either. Not in the domain. What about this last one? -1 to 4 of f of x plus h of x. F of x is possible, but not the h of x, not in the domain. Do you guys see that? So not possible. Not at the moment, at least. ATM. Actually, not possible, period, because they don't give you any extra information. Not possible. H of x outside domain. Are we okay? Okay. All right, let's go to the next question, guys. All right. The regions A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The region A is 18, so this is, now, okay, before you write anything down, is this region A below the x-axis? So put -18. Area itself is always positive because there's no such thing as negative area. But because it's below the x-axis, it's negative. What's the official term? Let me give you the official term for that. It's called signed area. Because area itself is never negative. So it's called signed area. The area of region B is 14. So what am I going to put down here? -14. And the area of region C is 8. 8. What is the value? So they want the area under the curve from -5 to 8 of this function. Okay, well, I go to -5, I start, and I stop. So I put my start and stop features. Start, stop. And I'm literally just going to add them up. I start at -5, so that means -18 plus -14 plus 8. If you do it like this, you will never mess up. So -18, 8, -10, -24, -14, -10, -24. So this answer is -24. It's talking about signed area. How do we feel? Not bad, right? Okay, so let's do one together. This is not with geometry here. So let me pause this while I... Okay, the function f is shown below. What is the value from 0 to 9 of f of x dx? Write your answer in simplest form. So let me screen capture this. Oh, it didn't screen capture at all. Hold on, guys. I did this morning, so I'm going to have to print screen. Let me get out of there and then control print screen and then open this and then new section, add page, boom. Okay. There we go. Oh, this is handy. Okay, here we go, guys. Ready? I want the area. So I want the area from x equals 0 all the way to x equals 9. And we're talking about bounded area between the x-axis and the curve. So I want this area here, and I want this area here. I think you can do this with a trapezoid. Do you want to do it with a trapezoid, or do you want me to break it up into regions? Triangles and rectangles. Okay, that's fine. Triangles and rectangles. Okay, look at this. From 0 to 4, that's a triangle. My width is 4, so I'm going to go 4. The height is 2, but negative. So don't worry, I'm going to turn it into now divide by 2. 4 times 2 is 8. Divided by 2 is back to 4. But because it's below the x-axis, that is -4. Are we okay? And then I see a triangle right here. Do you guys see that triangle right there? All right. So 4, 5, 6. That base is 2. That height is 2. 2 times 2 is 4. Divided by 2 is 2. So this area is 2. Are we okay? So there it is. And now look at this. This is just a rectangle. 1, 2, 3, and 2. 3 times 2 is? All right. So -4 plus 2 plus 6. So let's see. What's that? 6, 7, 8. So 4. All right. Time out. I've been seeing a lot of this, and I want to mention it right now. You see how I got a 2 and you see how I got a 6? Some of you love to just go plus 2 plus 6, and you put that on paper. Why is that wrong? Guys, look at what you just said. You just said that the left equals the right. This is called the linkage error. 4 times 2 divided by 2 is 4. See? No, I'm telling you, if you do this in the free response, we're going to count it wrong. The left side equals 4. The right side... Uh-oh, well, that's a negative there. Why is this... Okay, well, that's fine. Leave it at that. The left side equals 4. The right side, look, 6, 7, 8, 9, 10, 11, 12. Look what you just told me. You just told me that 4 equals 12. Is that a true statement? That's a false statement. This is called, what type of error is this called? Linkage error, because you just link random stuff to whatever you originally had. Stop doing that. You guys do that all the time. Stop it. Okay. What was the answer for this? 4, right? 6, 7, 8. Okay, yeah. So check it out. I'm going to go to my delta, and I'm going to type in 4. Sorry, it's taking me a while here. 4, submit, and zoom out. Yes, and there it is. Look, check it. Look, they did it with 2 formulas. They did a trapezoid: base 1 plus base 2 times height divided by 2. I bet you that's what they did down here, or not. Never mind. I thought they would have done it with a. Oh yeah, nope. They broke it up into triangles and rectangles. They didn't even do a. That's fine. No big deal. Cool or not cool? Can we do this? All right, that's it, guys. You're loose. Have fun.